students, this is Neelam. We are into study chemistry subject, and that's true. Organic chemistry I'm going to deal with you all. So I'm going to teach organic chemistry, and this is session number 1 belonging to the chapter name as such, Aliphatic Hydrocarbon. Now what do you understand by this name aliphatic hydrocarbon? You should understand that headline first. Then what are the different types of reactions are there that we need to understand, and the most important criteria to begin with the reaction, you should know different aliphatic compounds and different the cyclic compound, open chain compound. This main thing, first basic thing, you should know it, and then we have to go step by step about this chapter in more detail. Okay, now first we'll start with the name, headline of the chapter, which says aliphatic hydrocarbon. Now what do you understand by the word hydrocarbon? First we'll understand hydrocarbon and then aliphatic. Now what is the meaning of the word hydrocarbon? Hydrocarbon is having two elements into it. It is a combination of two elements into it. Now this is the compound wherein two molecules, or inside I can say two elements are into it. Okay, now it can be splitted into two words wherein it says hydrogen and carbon. So these are the two important elements which is present inside this hydrocarbon. So that is the meaning of the word hydrocarbon, where two elements like hydrogen consisting of hydrogen and carbon. Okay, then let's understand the second term, which is aliphatic. Now in order to begin with the aliphatic, you must know that organic compound is broadly classified into two categories or into two types. So organic compounds are classified or categorized into two parts. First one is open chain compound, and second one is closed chain compound or cyclic compound. Cyclic or closed chain compound is more than enough. Closed chain compound, or it is also called as cyclic compound. Okay, so what is the organic compound is made up of? Organic compound is consisting of two types, open chain compound and the closed chain compound or cyclic compound. Now in open chain compound, here what will be going to happen over here is that the hydrocarbons will be present in simple open chain, right? Suppose this is the hydrocarbon, and this hydrocarbon will be present in a simple skeletal form of straight chain. Okay, so that is the meaning of the word open chain organic compound, whereas closed chain organic compounds are those compounds wherein the hydrocarbon will be present into like this, into closed chain with the alternative double bond and single bond, like that. Understanding my point? So they will be present in the closed chain, okay, having particular shape like hexagonal shape, pentagonal shape, octagonal shape, depending upon the number of carbon atom and hydrogen atom into that molecule. Right, so that was all about the classification, open chain compound and the closed chain compound. Now this aliphatic hydrocarbons are basically open chain compounds, so we are going to emphasize only upon the open chain compound. Closed chain compound we are not going to study in this chapter. Okay, now what are the different types of compounds belonging to the open chain or the aliphatic compound, that we are going to study over here. Now let's understand the aliphatic hydrocarbon in more detail by taking the specific definition over there. Now aliphatic hydrocarbons are those hydrocarbons which contains open chain of carbon atom. Now here the carbon atoms will be present in the open chain, means the skeletal form of that molecule will be in the straight form. It will not consist of any cyclic form, it does not have any closed ring shaped form, nothing like that. It will be having a simple open chain skeletal formation. Okay, now hydrocarbon containing open chain of carbon atoms are called aliphatic hydrocarbon. Those are called as aliphatic hydrocarbons. Now in this aliphatic hydrocarbons, there are three important compounds coming under it. Okay, in this aliphatic hydrocarbons, there are three important compounds coming under it. First one is alkanes. Okay, I guess you guys have been understood with this. Let's understand the three types of compounds which are coming under aliphatic hydrocarbon. First one is alkane. Second one is alkene. Third one is alkyne. Okay, these are the aliphatic hydrocarbon. Now here you can see ALK is similar to all the three compounds. What is getting varied is the suffix. Here ANE is there, here ENE is there, here YNE is there, right? And that's true, only in the alphabet it is getting varied. Okay, so these are the three compounds belonging to the aliphatic hydrocarbon. Now this alkane we are going to study in more detail in this first session. Then afterwards we will talk about the alkene and alkyne. These three important compounds which is belonging to aliphatic hydrocarbons, they are the family. Okay, these are the family belonging to the major family which is called as aliphatic. Now each individual family will have their own family members. Common thing, I am just saying that thing, but those common whatever the family members are going to come into that, they have been assigned with a certain general formula that we'll study later on. But you need to understand that these are the three important compounds coming under the aliphatic hydrocarbon. Now here we are going to emphasize upon the alkane. Okay, now what are the alkanes? Now alkanes are saturated hydrocarbon. Alkanes are saturated hydrocarbon. What do you understand by the word saturated? Means here the carbon single bond will be present. Means between, if any carbon is there, carbon number 1 here is there, carbon number 2 is there, carbon number 3 is there, like so if one carbon has to be get linked with the another carbon, there should be certain bond, chemical bond between them, right? So only one single chemical bond will be present between the carbon-carbon atom. Right, so that is the meaning of the word saturated. Understanding my point? So these are the saturated hydrocarbon containing single bond between the carbon-carbon atom. Whereas alkene is also aliphatic, but here alkene and alkyne are unsaturated hydrocarbon. They are unsaturated hydrocarbon because here in alkene between carbon-carbon there will be double bond. Whereas in alkyne, the carbon-carbon will have triple bond between them. Between the two carbon atoms, there will be a triple bond in alkyne, whereas in alkene, carbon-carbon double bond will be present. Understood the point? So this is the basic difference between alkane, alkene and alkyne. Whereas alkane is an aliphatic hydrocarbon, basically it is saturated containing carbon-carbon single bond. Alkene is also aliphatic provided here the carbon-carbon double bond present will be there because it is unsaturated. Similarly, alkyne is also the unsaturated compound containing carbon-carbon triple bond. Okay, so that was all about the alkane, alkene, alkyne. Alkene and alkyne we'll study later on. First we'll focus only upon the alkane family. Okay, now if I want to talk about the alkane, you should know certain general formula of the alkane, then we'll carry out further the members which are belonging to the alkane family. Okay, now let's go towards the number of members belonging to alkane family. Okay, now general formula for the alkane is CnH2n plus 2. So this is the general formula for the alkane. Okay, now wherein N says that number of carbon atom present, okay, that may be 1, 2, 3, 4, anything. So it may be 1, 2, 3 and so on, number of carbon atom present into that compound. Okay, this is the general formula for the alkane. I repeat once again, the general formula which is belonging to the alkane family is CnH 2N plus 2. CN H2N plus 2. This is very, very important, children. If you done any mistake with this general formula while writing the number of members belonging to this family, it becomes very much, unpredictable for you guys to write down how many number of carbon will be there, how many number of hydrogen will be there. That becomes little confusion over there, because similarly how the alkane is having the general formula, alkene and alkynes are also having the general formula. So you just have to remember that alkane is having a general formula, so called CnH2n plus 2. Okay, so let's begin with the carbon number 1. Carbon number 1, the first family of the alkane. Now if carbon is 1, so let's write down, now formula was CnH2n plus 2. Okay, the carbon is how much? 1. Depending upon the number of carbon, you have to substitute N with that particular number. Now I am going to use 1 for the carbon, first carbon. Now N is nothing but 1 H 2 into N. N is how much? 1 plus 2. So this will be CH 2 1s are 2 plus 2. So this becomes CH4. So what is the name of this? CH4. This is a molecular formula. CH4 is a molecular formula. The name for this is methane. We got first member of the alkane, which is methane. So this is the methane, CH4. Now if I am writing the molecular formula, you should know the structural formula. Each and every compound will have the two names. One is the molecular formula and the structural formula over there. The two formulas will be there, not name, the formula. Name, if I consider, that will be the IUPAC name, wherein you are studying from your PU level itself. Now I am talking about the formula. So CH4 is a molecular formula and the name for it is methane. Let's draw the structure for it. How the structure for the methane will be? We know that carbon atom will have valency 4. Means carbon atom can bind only with the 4 different hydrogen atom, and means different element, because 6 is the atomic number of carbon. This is very basic. 6 is the atomic number of carbon. So its electronic configuration will be 2, 4. Means it will have 4 electron in its outermost shell. If it is having 4 electron in its outermost orbit, that means it can make only 4 bonds, not more than 4 bonds. So that is the valency of carbon. So carbon is having a valency 4. So here only one carbon is there. So it becomes very simplified for us to draw the structure for methane. So the structure for methane will be like 1 carbon in the middle and 4 hydrogen will be present periphery to each. So this is how the methane structure will be. Okay, central carbon atom, 4 hydrogen atom will be present in the periphery. So this is the first member belonging to the family so called alkane with the formula CnH2n plus 2, which is called as methane. Okay, now let's go towards the second family member with the carbon number 2, right, and utilizing the same general formula CnH2n plus 2, right. So let's do for the second carbon with the same formula CnH2n plus 2. Okay, now here 2 carbon atom is there, so this will be 2 into 2 plus 2, so this becomes C2H4 plus 2, so this becomes C2H6, right. 4 plus 2 is 6. So here totally 2 carbon is there and 6 hydrogen is there. The name for this compound is ethane. Ethane. It is very simple. It is very simple. You just have to substitute the number of carbon atom into it. That's it. So the name for this compound is ethane. So if here 2 carbon and 6 hydrogen is there, and we are studying aliphatic hydrocarbon. So now this 2 carbon, it will present only in the straight chain. It will not going to present or form any cyclic formation over there, right. So 2 carbon, let's draw the structure of ethane here. 2 carbon is there, correct. So 2 carbon will be linked with 1 bond between them. Now I said the valency for carbon is 4, means it can bind only with the 4 hydrogen atom, not more than 4, right? So 4 bond formation will be took by each carbon atom. Only 4 bond will be going to get formed over there. By each carbon atom will form 4 bond. So carbon number 1 and this is carbon number 2. Okay. Now carbon number 1 will make a 4 bond. Already 1 bond is here. Now how many more bond is needed? 3 bond. 1, 2, 3. Done? Okay. Now let's talk about the carbon number 2. Second carbon atom also needs 4 bond. Now 1 bond is utilized to get combined with the another carbon atom, neighboring carbon atom. The remaining 3 bond it will be going to get utilized to form a bond. 1, 2, 3. Right? So this is how each carbon atom will be going to get formed, linked either by carbon-carbon atom, and the 3 bonds which are there, each carbon atom, they will be going to get linked with the hydrogen atom. So how many hydrogen atom is there totally? 6 hydrogen atoms are there. So let's write down 6 hydrogen. 1, 2, 3, 4, 5, 6. Okay, done with this. So this becomes the structural formula for ethane. Okay, so this is the structural formula for methane with the molecular formula CH4. Ethane is having a molecular formula C2H6 and the structural formula which is present in the straight chain is in this manner, where 2 carbon atom will be going to get linked with each other and the remaining 3 bond will be going to get utilized to get attached with the remaining number of hydrogen atoms. Okay, so this is how the methane and ethane will be there. So first family member of alkane is methane. Second family member of the alkane is ethane. First family member of alkane is methane, second is ethane. Okay, now let's go towards the third carbon atom. So I'm going to go through only 5 carbon atoms, which are very, very basics. So 5 carbon atoms will do, and later on is also very simple. You can do this by just adapting the general formula CnH2n plus 2. Okay. Now we'll go towards the third carbon atom. Third carbon atom or third member of the alkane. Third member of the alkane is, so C is equal to 3, that means N is equal to 3. So what was the general formula? CnH2n plus 2. So this is the formula for alkane, general formula for alkane. Now here N is 3. So let's substitute that 3 over there. So H is equal to 2. H is nothing but in the subscript form you need to write down. In place of N you are going to substitute 3 plus 2. Correct? So this becomes C3H, 2 3s are 6. Plus 2. So C3H8. So this is the molecular formula of next third carbon atom, and the name of this is propane. The name of this family member is propane. First one was methane, second one was ethane, third one is propane. Now if I want to write down the structure for this propane, that's you need to write down in the skeletal form, straight form. Okay, open chain compound will be there. Let's write down this open chain compound with the propane with 3 carbon atom over there. Okay, let's write down, draw that structure. 1, 2, 3. So these are the 3 carbon atom. First they are going to link with each other. Okay. And now remaining bond are there, that will be going to get utilized to get bound with the bind with the hydrogen atom. Okay, so the remaining one I'm going to draw in this manner. Done. So each carbon atom will be going to get bind with the 4 different atoms. Okay, this first carbon atom is getting combined with the second carbon atom. So here 1, 2, 3, 4. Second carbon atom, let's talk about the second carbon atom. Here also the valency of the carbon which should be 4, not more than 4. So 1, 2, 3, 4. Third carbon atom the similar way. 1, 2, 3, 4. So this is how the bond formation will be going to take place between the carbon-carbon and the remaining which is there, that you need to satisfy with the number of hydrogen atom over there. Now how many hydrogen atoms are there? 8 hydrogen atom. Okay, let's write down those 8 hydrogen atom. 1, 2, 3, 4, 5, 6, 7, 8. Done. So this is how the structure of propane will be. Okay, so this is the third member of alkane. This one is the third member of alkane. Now let's talk for the fourth member of alkane. Okay, let's write down for the fourth member the molecular formula as well as the structure formula for the fourth member of alkane. Okay, now for the fourth member of alkane, we know that carbon number is 4. That means number of carbon will be 4 over there, right? So it will have general formula CnH2n plus 2. So here n is 4. I am going to substitute n with 4, and H is nothing but 2 into 4 plus 2. Substituting, n with 4, that's it. So this will be C4H, 2 4s are 8 plus 2. That means totally 10 it will be. Hydrogen, total number of hydrogen in butane means 4 carbon atom. The molecule with the 4 carbon atom will be 10. So C4H10. So this is the molecular formula for the next compound whose name is butane. Butane. Okay, so this is how the butane molecular formula would be, and now let's draw the structure for it. After drawing the structure, that becomes more simplified for you guys to understand how the butane structure formula would be look like. Now here how many carbon are there? 4 carbon are there. So let's draw the structure of 4 carbon with the skeletal, straight chain. We are talking only about the aliphatic hydrocarbon, means it is open chain or straight chain. So 4 carbon atom, 1, 2, 3, 4. So these are the 4 carbon atoms. Now the remaining bonds, they are going to get satisfied by getting attached with the number of hydrogen atom. Okay, each carbon will going to get bind with the 4 element, not more than 4 element over there. So this is the carbon number 1 is having 4 valency, 1, 2, 3, 4. Okay, now carbon number 2 is also having 4 valency. How come? This bond is there, no? Middle bond. It is going to get share that bond between the carbon atom, right? So carbon number 2 will have again a 4 valency by making the 4 bonds, 1, 2, 3, 4. Similarly, carbon number 3 and carbon number 4 will satisfy by having the 4 bonds, right? So now here the remaining bonds will be going to get going to bind with the hydrogen atom. So here hydrogen atom will be going to get attached to it. The remaining bonds are going to get satisfied by getting attached to the or binding to the hydrogen atom. Now how many number of hydrogen atoms are there? Totally there are 10 hydrogen atoms. So let's count over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. So this is the structural formula for the butane. Okay, so first one was methane, second one was ethane, third one is propane, fourth one is butane. Okay, now let's talk about the fifth carbon atom, right? If N is 5, what will be the molecular formula for that compound, and what will be the structural formula for the particular carbon number 5? Let's draw that with 5 carbon atoms. So with 5 carbon atoms, how the structure will be, or how the molecular formula of that compound will be. Let's do that. Okay, now fifth one with 5 carbon atom. So N is how much? 5. And we are going to substitute 5. So here C5H 2 into 5 plus 2, right? So this is how the formula would look like, wherein 5 hydrogen, and you have to not 5 hydrogen, since here carbon is 5, you have to substitute N with the 5 over there. Now here C5H 2 into 5 is 10 plus 2. So this becomes C5H12. So this is the molecular formula for the next member belonging to the alkane, and the name for this is pentane. So remember, in alkane we are writing the suffix with ane, alkane, right? So alkane is having the suffix ane, correct? So all the alkanes whichever we have been studied right now, methane, ANE is there, ethane, ANE is there at the last, propane, then similarly you can see over there in butane, ANE is there in the suffix. Now pentane is also having ANE over there. Now let's write down the structural formula for the pentane. Now this is the molecular formula for pentane. Now let's write down the structural formula for the pentane. Then it becomes very simplified to understand the further reactions. If you know these basics members of the alkane, you can do the n number of reaction, you can understand the n number of reactions over there. So if 5 carbon atom is there, so let's write down first 5 carbon atom. 1, 2, 3, 4, 5. These are the 5 carbon atoms which are going to present in the straight chain, in the straight skeletal form. Right, so the remaining bond will be going to get satisfied by getting attached to the number of hydrogen atoms which is present into that formula, molecular formula. Okay, and you know that each carbon atom will have the valency of 4, that means it will be going to get bind with only 4 different atoms over there. One bond is already utilized by the carbon atom by getting attached to the neighboring carbon atoms. So the remaining 3 bonds are there, no? So they are going to get utilized to get bind with the hydrogen atom. First carbon atom and the last carbon atom, here the 3 bonds they are going to utilize to get bind with the hydrogen atom, and the remaining middle bonds are there, middle carbon atoms are there, no? From carbon number 2 to carbon number 4, here already there 2 bonds are utilized to get bind with the neighboring carbon atom, and the remaining 2 bonds they are going to use for getting attached with the hydrogen atom. Remember the terminals carbon atom, terminal means which are present at the end in the straight chain, they will have 3 bonds that will be going to get attached towards the hydrogen atom, wherein the 4th bond will be going to get shared to get attached to the neighboring carbon atom. Whereas the remaining middle carbon atoms are there, no? They are going to have 2 bonds to get attached with the hydrogen atoms, and the remaining 2 bonds they are going to get shared to get bind with the neighboring carbon atoms. This is a basic difference while writing down the structure of that particular molecule. So here since 5 carbon atoms are there, 1, 2, 3, 4, 5, right? 5 carbon atoms are there and 12 hydrogen atoms are there. So let's write down these 12 hydrogen atoms. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is how the structure of pentane would be, right? So these are the 5 members of alkane. Up to 5 you should know it, right? As per this, aliphatic hydrocarbon, we just have to go through different various reactions. So up to 5 you should know into your mind the molecular formula as well as the structural formula of those 5 carbon compounds which are belonging to towards the alkane. So let's do the recapitulation. First member of the alkane is methane. Second member of the alkane is ethane. Third member of the alkane is propane. Fourth member of the alkane is butane. Fifth member of the alkane is pentane. So these are the 5 members of the alkane family belonging, right, wherein you can see in all that the suffix will be ane. All that the suffix will be ane, and they have been named according to the number of carbon atom present into it. So all these are aliphatic hydrocarbon, wherein these molecules will be present in the straight chain or the open chain, and they will possess a single bond between carbon-carbon atoms. So you can see from here how many structure we have been wrote from the first methane till pentane. You can see only one bond is there between carbon-carbon atom. Right, so thereby it is called as alkane. Now let's talk about the reactions which are coming under this alkanes. Okay, now we are going to start with a new topic, and the name of the new topic is catalytic hydrogenation. From here we are going to study the preparation method. Now preparation method means what? Now whatever up till now the 5 members of alkane you have been studied, so called methane, ethane, propane, right, butane and the pentane. So these are the 5 members. How these 5 members will be going to get prepared by utilizing different compound. Now what do you understand by the word preparation? Preparation means you need to prepare alkane. You need to prepare alkane by taking certain reactant. Any reactant depend upon the method, depend upon the preparation method, depend upon the process which you are going to take place over there. The main motto of preparation method is that you are going to prepare alkane as a main product by utilizing any two reactant depend upon the process wherein you are going to study over there. Okay, now let's begin with the first process of preparation, which is catalytic hydrogenation. Catalytic hydrogenation. Now what do you understand by the word catalytic hydrogenation? Here we are going to use catalyst. We are going to use catalyst, and hydrogenation means here the reduction process will be going to take place. Now if any A is any reactant, B will be for sure it will be hydrogen gas, and this reaction will take place in presence of certain catalyst to form a main product called as alkane along with certain byproduct. If byproduct is formed, okay, not from, it's also okay. Okay, so this is the reaction. Catalytic reaction says that where you are going to use catalyst for the reaction in presence of hydrogen as a main reactant. Okay, so here the reduction of the first compound will be going to take place. What is reduction? Reduction is nothing but addition of hydrogen plus it is gain of electron. From electron point of view it is gaining of electron, but from hydrogen point of view it is the addition of hydrogen towards any reactant. Okay, so you are going to study the catalytic reduction, hydrogenation. By this process we are going to prepare alkane as a main product. Now which kind of a reactant we are going to use and which kind of a catalyst we are going to use, that is the question mark over here. Now let's see which kind of a reactant we are going to use along with the hydrogen. The first main reactant is there, now which kind of a reactant we are going to use and what are the names of the catalysts wherein we are going to utilize over here. Now here a mixture of unsaturated, the word unsaturated came. Unsaturated hydrocarbon means what? Alkene and alkyne. Initially I said alkene and alkyne, those are unsaturated aliphatic hydrocarbon, means here between carbon-carbon there will be double bond. Right? In alkene there will be double bond, in alkyne there will be triple bond. So these are unsaturated hydrocarbon. So I am going to use here unsaturated hydrocarbon and hydrogen. So here the mixture is made of what? Unsaturated hydrocarbon and the hydrogen, which is passed over the finely divided catalyst, so called platinum, palladium or nickel. So these are the catalysts. Okay, so the first main reactant, A reactant is unsaturated hydrocarbon. B reactant, yes, it is hydrogen gas. Now what are the catalysts? The catalyst may be platinum, second one is palladium, or it may also have nickel as the main catalyst. So this is what the reaction says, and you are going to form alkane over here. Alkane as a main product. So that was all about the reaction. Okay, so what is the reaction is saying? A mixture of unsaturated hydrocarbon is passed over along with hydrogen gas. Unsaturated hydrocarbon along with hydrogen gas is passed over in finely with the presence of finely divided particles of catalyst are used, which are platinum, palladium and nickel, to form a main product, so called alkane. Okay, let's take the general reaction, general example, and we'll take certain more examples for it. Now general reactions. Now this is an alkene. Okay, generally it is an alkene. Now alkene, we know that it has a double bond between the carbon-carbon atom. Now if this is a carbon number 1 and this is a carbon number 2, now carbon number 1 is having 4 bond. Let's see how it is having 4 bond. 1, 2, 3, 4. Carbon number 2 is also having 4 bond. 1, 2, 3, 4. Now this carbon-carbon, carbon number 1 and carbon number 2, they are having double bond between them. That means these bonds are getting shared between them. These bonds are getting shared between them, and thereby each carbon atom will be going to get balance the valency, whatever it is there. okay, with 4 valency. Now this is an alkene. Now alkene has to react with the main second reactant, which is hydrogen gas, H2. I'm splitting that in the form of H2 like HH. Okay, so this is hydrogen gas, and this reaction is taking in presence of important catalysts, so called platinum, palladium or nickel, and the temperature is also given to it at around 523 to 573 Kelvin. Okay, so here generally an alkene, which is an unsaturated hydrocarbon, is passed along with hydrogen gas in presence of finely divided nickel, platinum or palladium as a catalyst. You are going to form, or we are going to form, an alkene over there. So here whatever the double bond is there, carbon atom, this will be going to undergo reduction, means that double bond will be going to get broke down and it will form a single bond over there. So if any chemical reaction we are talking there, breaking and making of bond will be going to take place in any chemical reaction. So first breaking will be going to get happen, and then the making of new bond will be going to get happen over there. So here now this hydrogen atoms are there, no? These hydrogen atoms will go and get bind to each carbon atom. They will go and get bind to each carbon atom, and they are going to bind from the same side. It's not like that if like this is there, if like this is there and the hydrogen atom is there, this hydrogen atom, if it is going and getting bind to carbon atom first like this downside, and the another hydrogen atom towards the another carbon atom upside, so this is not going to get happen. Anti-position will not going to get happen. The stereochemistry of that carbon atom will be, they will be in the syn position, same side. Along the same side, this two hydrogen atom will be going to get attached to individual carbon atom. Okay, and thereby the reduction of that carbon atom is happening, and you are getting the alkane over there. Now let's see once again how that reduction will be going to get happen. Let's see once again. First, double bond, this is the alkene, general alkene, general it is an alkene. Now here the hydrogen gas is passed in presence of what? Platinum, palladium and nickel, or nickel actually. Okay, now this carbon number 1 and this is carbon number 2. Now this bond will be going to get break. Okay, the bond breaking will be going to take place in such a way that the hydrogen atom will approach, after the bond is broken, it will approach to the individual carbon atom towards it, and thereby you are going to get form the single bond between the carbon, right? So one bond, basically one bond will be going to get break over there to form a single carbon bond. So this is how from unsaturated hydrocarbon it is getting converted into saturated hydrocarbon. Unsaturated aliphatic hydrocarbon is getting converted into saturated, means from alkene it is getting converted into alkane simply by addition of hydrogen. Simply by addition of hydrogen gas, means it is undergoing reduction. So this reduction process will basically take place between carbon-carbon double bond. Carbon-carbon double bond. So let's take the several example, then you will understand in more detail. Okay. Now first example we'll take for propene. Propene is that alkane which is containing 3 carbon into it. Propene is that alkane which is containing 3 carbon into it. So let's write down the 3 carbon first. 1, 2, 3. Now if I am talking about the propane, propane is an alkane, means it has a double bond. It will have a double bond obviously. So one double bond I am going to put between this is suppose carbon number 1, carbon number 2 and carbon number 3. Now between carbon number 2 and carbon number 3 I am putting one double bond over there. Okay. So after drawing that double bond over there, now let's satisfy the remaining bond with the number of hydrogen atom over here. So let's draw that. Okay. Now see, you have to see whether it has been balanced or not. Carbon number 1 is having 4 bonds, done. Carbon number 2 is having 4 bonds, 1, 2, 3, 4. Now let's talk about the carbon number 3, which is also having 1, 2, 3, 4. Okay, done. So this is what? This is propane. in means at one between whom and whom the double bond is present is between carbon number 2 and carbon number 3, the double bond is present. So thereby its IUPAC name will be like the similar. If you don't write 1 also, it's okay, but if you just have to take from the reverse 1, 2, 3, not in this position, because according to the IUPAC nomenclature you have been studied in your 12th standard, you have to start numbering by giving the preference where the double bond is first present. Okay, so you just have to start numbering from the reverse, like 1, 2, 3. So this becomes propene because it is present between carbon number 1 and carbon number 2. So the lowest preference you have to take is 1. So this is totally propene. Directly you can write down like that. Now in this propane you are going to add hydrogen gas, right? So once you add it with the hydrogen gas, we know that the reduction will be going to take place between carbon-carbon double bond. Now carbon-carbon double bond is present between carbon number 1 and carbon number 2. So here the reduction will be going to take place between these two carbons, carbon number 1 and carbon number 2, right? So once the reduction is took place, the one hydrogen atom will approach towards the carbon number 1 and the another hydrogen atom will approach towards the carbon number 2. So after the approachment is done, and this reaction, yes, we have to write down, this reaction is taking place in presence of platinum, palladium or nickel. This is very, very important, which says catalytic reduction, hydrogenation is taking place. Catalytic hydrogenation is taking place. In presence of catalyst, the hydrogenation is taking place, means addition of hydrogen is taking place, right? So the main product which is going to get formed over here is alkane, right? So from this double bond it is getting converted into single bond. The reduction of the bonds are going to take place over there, right? Carbon atom is going to take place. So it will be CH3, then 3 carbons were there, right? So CH2, this will be also CH3. Why this form? Because this 2 hydrogen atom has approached towards the individual carbon atom. First hydrogen will go towards the first carbon, second hydrogen will go towards the second carbon. So thereby it will bring about the reduction of bond over here. It will just going to be break and it will going to get attached over there. So that is how the propane is getting converted into propane. It is getting converted into propane, means from alkene it is getting converted into alkane. Okay, so remember that whenever the carbon-carbon double bond is there, only the reduction will be going to take place, right? So suppose if you are going to write double bond over here between carbon number 3 and carbon number 2, then you have to start writing 1, 2, 3 like in this manner according to the IUPAC nomenclature you have been studied in your 11th and 12th standard over there. Now let's talk about the second example, which is I am going to take is butene, right? So in butene there are 4 carbon atoms. In butene there are like butane. Here it is butene. Alkene is formation is butene. So here 4 carbon atom will be there. 1. Okay, let's write down little bit there. So that becomes more easy for us to write down the remaining one. Butane. Okay, 4 carbon will be there. 1, 2, 3, 4. Okay, now I am going to write down for but2ene. But2ene means between carbon number 2 and carbon number 3 double bond will be there. So lowest preference I am giving for the second carbon. So 1, 2, 3, 4. These are the 4 carbon. Now between 2 and 3 the double bond is there. Between 2 and 3 the double bond will be there. Correct. So after writing down the double bond, I am putting 2 over here in the middle, means lowest preference carbon atom you have to write down while writing the IUPAC name for that. So the remaining bond will be going to get satisfied with the number of hydrogen atom towards it. Okay. But you have to remember the valency of carbon, then only you have to do the things in appropriate manner, right? So carbon number 1 with 3 hydrogen, 4 valency is done. Carbon number 2 with 4 valencies, 1, 2, 3, 4. Carbon number 3, 1, 2, 3, 4, right? Whereas 4, 1, 2, 3, 4, done. That is done over there. Now let's do the reaction with hydrogen. And this, when the hydrogen gas is passed in presence of what? Most important catalyst, which are platinum, palladium, or nickel. These are the most important catalysts wherein it is used for the hydrogenation. Okay. Now here we said that the reduction will be going to take place between carbon-carbon double bond. The alkene has to get converted into alkane, means unsaturated hydrocarbon has to get converted into saturated, where it will be going to get happen between the double bond, right, between 2 and 3, carbon number 2 and 3. So here these two hydrogens are there, they will approach towards the individual carbon atom in this manner, right. So once they have been approached, the bond will be going to get broken over there and it will be going to get converted into single bond, right. So after the bond is broken down, let's write down 4 carbon, right. So between carbon number 2 and carbon number 3, initially only 2 hydrogen were there, but here the 3, remaining 2 hydrogen, it will come from where? It will come from the hydrogen gas. So the remaining hydrogen, just balance it by writing down that. So this has been converted from but2 into butane. So from but2 it has converted into butane. So alkene is getting converted into alkane. The unsaturated hydrocarbon is getting converted into saturated hydrocarbon by just breaking the double bond which is present between the carbon-carbon atom, and that is done in presence of platinum, palladium or nickel. Okay. Now let's take the one more complicated example with large number of carbon atom into it. That example will take, then it will be more understandable for you guys. Okay. Let's take the pentene. Pentene is that carbon which is having 5, or that compound which is having 5 number of carbon atom into it. Okay. So let's take third example, pentene, which is having 5 carbon atom into it. 1, 2, 3, 4, 5. Okay. Now I am going to write down the molecule whose name is pent2in. Means here between carbon number 2 and carbon number 3, the in will be there. The in means double bond will be there, right. So let's number it 1, 2, 3, 4, 5. Between carbon number 2 and carbon number 3, double bond is there, right. Now let's balance that by writing the number of hydrogen atom into it. So this terminal carbon will have 3 hydrogen, we know that, because the valency has to be satisfied 1, 2, 3, 4, right. Now the remaining one, 4th hydrogen atom, 4 valencies, and this one, 3rd carbon is 1, 2, 3, 4, and then the remaining one is also having this 1, 2, 3, 4. Like this you need to write down, right. So this is pent2in. Now this is unsaturated hydrocarbon, alkene with double bond into it. Now I need to convert it into single bond saturated hydrocarbon by addition of hydrogen gas, and that is taking place in presence of platinum, palladium or nickel as a main catalyst, right. So this hydrogen gas, 2 hydrogen atoms are there, they are going to get approached towards whom? Carbon-carbon double bond. Remember, that has to be broken down into the single bond, right. So that is the meaning of the word reduction. Reduction is addition of hydrogen atom. Reduction is addition of hydrogen atom. So these 2 hydrogen atoms are going to get approached towards the individual carbon atom where the double bond is present. Okay. So this hydrogen number 1 will approach towards the first carbon. The hydrogen number 2 will approach towards the second carbon, right. The moment they approach over there, they are going to bond with those carbon atoms. So after getting binded up, the molecule will look like, first I will write down the carbons, number of carbons, 1, 2, 3, 4, 5. Okay, these are the 5 carbon atoms. Now we know that between carbon number 2 and carbon number 3 the double bond was there, but that has been splitted down, means it has been broken down to a single bond. So these are the 2 hydrogen atom which has come from this second reagent, right. So these are the 2 hydrogen atoms between 2 and 3, and the remaining hydrogen just write down as it is, right. So this is how the pent2in is getting converted into pentane, means the alkene is getting converted into alkane, The double bonded compound is getting converted into single bond compound. This unsaturated compound is getting converted into saturated hydrocarbon, right? So this is very, very important, children, from an examination point of view. Catalytic hydrogenation means what? Here the unsaturated hydrocarbon will be going to get converted into saturated hydrocarbon simply by reduction process. Reduction means by hydrogenation, by adding hydrogen towards the carbon-carbon double bond in presence of catalysts like platinum, palladium and nickel. So whichever alkene you are writing down, you just have to write down according to the number of carbon atom. For that you should know the number of alkene, the family's member of that alkene. Now for alkane, how you came to know? Similarly for alkenes also the families are there: ethylene, propylene, butylene, pentylene, or like ethene, propene, butene, pentene. So these are the members belonging to the alkenes. They are also having certain general formula, we will discuss later on. But in this reaction, this is the thing which is happening in catalytic hydrogenation. Now the second reaction we are going to take in the second session, and now from here onwards we are going to study only the preparation method. By adapting certain process, we are going to prepare alkane, right? And that process may be anything, depends upon the name of the reactions. So I think you guys have been understood with this session number 1, wherein we have been covered with aliphatic hydrocarbon, what is the meaning of aliphatic hydrocarbon, what is alkane, and the members which are belonging to the alkane with the general formula so called CnH2n plus 2. 5 family members, 5 members we have been studied belonging to the family so called alkane. Apart from that, we studied the preparation method, first preparation method, which is the catalytic hydrogenation. Now those 5 family members which I said you have to write down the remaining 3 family members, like with carbon number 6, 7 and 8, with the molecular formula as well as with the structural formula. Then you will understand in more detail over there. It's very simple, you just have to write down N has 6 and substitute into the general formula, N has 7 and substitute into the general formula. You will get the molecular formula, and accordingly by satisfying the valency of each carbon atom, you have to draw the structure which is there in the open chain form, not in the cyclic form. That is the meaning which is called as aliphatic hydrocarbon. So thank you class for watching this class. Thank you so much.